So in this video, I'm gonna discuss you all about in chapter 8 subnetting IP networks. First is octet boundaries. Every interface on a router is connected to a network. The IPv4 address and the subnet mask configured on the router interface are used to identify the specific broadcast domain. Recall the prefix lengths and the subnet mask are different way of identifying the network portion of an address. IPv4 subnets are created by using one more of the host bits as network bits. This is done by extending the subnet mask to borrow some of the bits from the host portion of the address to create additional network bits. The more host bits are the borrowed, the more subnets that can be defined. Creating subnets with 16 prefix. In a situation requiring larger number of subnets, an IPv4 network is required that has more host bits to borrow from. For example, the network address is 172.16.0.0, has a default mask of 255.255.0.0 or 16. This address has 16 bits in a network portion and 16 bits in a host portion. The 16 bits of the host portion are available to borrow the creating subnets. The highlights of possible scenarios of subnetting a 16 prefix. To to get the prefix of the uh, address, we will just count all the number one in the address. So subnetting based on host requirements. There are two considerations when planning subnets. The number of host address requires for each network, the number of individual subnets needed. The specifics of subnetting 24 network. Notice how there are an inverse relationship between the number of subnets and the number of hosts. The more bits borrowed to create subnets, the fewer host bits available. If more host address are needed, more host bits are required, resulting in a fewer subnets. So, we proceed to the chapter 8 subnetting IP networks. The process of segmenting a network by dividing into two multiple smaller network spaces is called subnetting. Every network address has a valid range of host addresses. All devices attached to the same network will have an IPv4 host address. For that network and common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnets without the use of a router. To determine if the traffic is local or remote, the router uses the subnet mask. The prefix and the subnet mask are different ways of representing the same things. The network portion of an address. IPv4 subnets are created by using one or more of the host bits as network bits. The very important factors that will lead to determinations of IP address block with the subnet mask are the number of subnets required and the maximum of number hosts needed per subnets. There are inverse relationship between the numbers of subnets and the number of hosts. The more bits that are borrowed to create subnets, the fewer host bits are available. There are fewer hosts per subnets. The formula is 2n, where n is the number of host bits remaining, is used to calculate how many addresses will be available on each subnet. However, the network addresses and broadcast address within a range are not usable. Therefore, to calculate the usable number of addresses, the calculation is 2n minus 2 is required. Subnetting is a subnet or using variable length mask VLSM was designed to avoid missing address. So, in this chapter, you were gonna learn how to get your subnet mask, your prefix. uh, you will see how to this is the formula: 2n raised to n, 2 raised to 1, 2 raised to 2 will get. If you use this formula, we'll get the subnet mask. Then the IPv4 subnets are created by using one or more host bits. To every important factor, so will lead determination of IP address block subnet mask. The number of subnets is required. You will get the required and maximum host by uh, calculating the required numbers of bits, and to get the prefix is to count the all the one all number one in the binary form, like 10111111. Can get, you will add, you will count it to and total it, and you will get the prefix. And that's all for chapter 8, subnetting IP networks. And that's all. Thank you.